today we're going to do writing linear equations in slope-intercept form. So, still more slope-intercept, but now we're writing equations. Okay, verbal. Miss Letts talks a metric ton in her videos, and her students try to convince her to cut back. Her first video was 27 minutes long, but she says she'll cut back 2 minutes per video. Okay, so you want to think about our units, right? We have minutes per video. So we're going to put here in our label, let's see if we can find, we're going to have video and time. And then our units are minutes and just videos, like count of videos or number of video. This pen's not very good. Okay, so let's just start, right? We know that our first video is 27 minutes long. And then our next video, we're going to cut back 2 minutes per video. So for the next one, we go 25, 23, 21. Okay, so a really important skill when you're getting a graph like this is to think about how to scale it, right? So we're going to put, this is our x, or independent, and then this is our y, our dependent, because the time is dependent on which video it is. So we know that our x and our y, we have 1 through 3, and there's a ton of lines, right? So let's just make like every 4 lines 1, just so that we can see it a little better. If we went that should be a 3. If we went 1, 2, 3 here, it would just be so scrunched up. We sort of want to spread it out a bit. So a better example that will be on the y-axis. So we know that we have 27 as our maximum and it keeps going down. So let's first see how many lines we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 lines and we have 27 as our max. So we can't have each line being 1 because 27 would be all the way up here. So the next best thing we could do is each line is equal to 2. So this could be 40. 1, 2, 3, 4, 5. This could be 10. 1, 2, 3, 4, 5. This could be 20. 1, 2, 3, 4, 5. This could be 30. So you have to make sure it's even, right? This doesn't have to match, right? This one was every 4 lines is 1, and this one is every line is 2. So it doesn't need to be the same scale on the x to y, but it can't change. We can't have 1 here, 2 here, and then 3 over here. It needs to be the same distance. So scaling graphs is very, very important. All right, so once you decide on your scale, then you can graph. So I have 0, 27, so 22, 24, 26, and then halfway. And then at 1, we have 25, 22, 24, halfway. At 2, we have 23, 22, halfway. And then 3, we have 21, so right above 20, and so on. So we're going to... This line, you got to be careful. So normally we put arrows on both sides, but when we're thinking of a real world application problem, like a word problem, we're not going to have -1 video. So the line is actually going to start here and keep going, but we don't want to draw it on the other side, right? That would be wrong. Okay, so with the graph, right, so we have our initial value is 27 minutes, and our rate of change is -2 minutes per video. So that would be -2. So if we were to write the rule, right, we could do y equals -2x plus 27. Okay, so how do we do this consistently? So we have steps to find an equation in slope-intercept form. So let's do with 1, right? We're going to find the slope. So we can either do it on a graph or using a formula. We have y2 minus y1 over x2 minus x1. On a graph, we would do rise over run. And then something to really note, right? Note the sign. So is it positive, negative, 0, or undefined. And you want to make sure it matches, right? Like this slope, we know it should be negative. So we have to make sure our number is negative because we can see visually from left to right it's going down. So be very careful with that. Okay, so first we find the slope. Then we find the y-intercept. So this is the place it crosses the y-axis, or the point where x equals 0, 0b, right? So this is a definition, this is a vocab word. Y-intercept has the x equals 0 and the y is something, or b, right? For y equals mx plus b, right? We can have y equals mx plus b, right? So we can remember this is our b, this is our slope, our y-intercept, color code. Sort of hard to see in the camera, but I have a purple and a green. Okay, and then the third step is our easiest step. Plug M and B into y equals mx plus b. Right? So that's what we did up here, right? We found the slope, we found the initial value, and then we plugged it into our equation. All right, so let's take a look at an example, a different example. So what is the equation of this line? Okay, so we have our steps, right? So we have 1, we have our slope equals 4, because they told us, right? 2, our y-intercept equals -6, because they told us. So 3, our final answer is y equals 4x plus -6. And we're just going to rewrite that because we don't like to have like a plus minus. I mean, you can, but right, it's nicer to just write y equals 4x minus 6. Right, that was super easy by design. They gave you the slope, they gave you the y-intercept. Let's do one that's a little harder, right? So 1, we need to find our slope. So we have m equals, and let's do rise over run. So we start here, we go up 2, we went over 3, so we know that our slope is 2/3, and we want to make sure, like, let's check it, right? It's positive, right? From left to right, it's going up, so this is positive, so we know that this is right? We know that this is a positive number, so we did that good. 2, we need to find our y-intercept. So if we look on the graph, we see where does it cross the y-axis? Right here at -1. And finally, we just plug it in. So y equals 2/3 x plus -1. And then we get y equals 2/3 x minus 1. Okay. Already on the third example, what is the equation of a line that passes through the following 2 points? Okay. So first we're going to find our slope, right? What color did I use for slope? Purple. So we have m, and we need to do, we don't have a graph, we can't see the rise over run, so we're going to do our equation. y2 minus y1 over x2 minus x1, right? So these are our y's, and these are our x's. So let's just, it doesn't really matter the order. It would probably be, some people like negatives in a certain way. It doesn't really matter. I'm just going to start with this one. -8 minus 1 over, then we do the 0 minus -3. We get -9 over +3 because 0 minus -3 becomes 0 plus 3. We get -3. And right, what if we had done the other points? It would have been the same thing, right? 1 minus -8 over -3 minus 0. We get +9 over -3, -3. Okay, 2, we need to find our y-intercept. So remember, our y-intercept is when x is 0. So our y-intercept is negative 8. Right? Because y equals 0 and 0, negative 8. And then 3, we just get to plug it in. Y equals negative 3x minus 8. Okay, write an equation for the line with the given values. Okay, so this looks icky, but it's just function notation, right? So function notation. What lesson did we learn that in? I think we learned it in 5.5. Let me double check. Yes, right? Function notation was from B05.5. So this is pretty much saying f of something equals negative 2, f of 4 equals negative 3. So if we remember, the things in here are x's. So let's actually just rewrite these points in point notation so that it looks a little more familiar, right? So we have 0, negative 2, and 4, negative 3, and now it's just like example 3, right? Okay, so 1, we have our slope, right? And this is y2 minus y1 over x2 minus x1. We have negative 3 minus negative 2 over 4 minus 0. We get negative 3 plus 2 over 4, which is negative 1 over 4. 2, we need our b. Well, we see here, right, x is 0 when x is 0, y is negative 2, so we know that it's negative 2. And then we just put it all together. Y equals negative 1/4 x minus 2. Alright. Now we get an application problem. The initial fee to have a website set up using a server is $48. It costs $44 per month to maintain the website. So write an equation that gives the total cost of setting up and maintaining a website as a function of the number of months it is maintained. Okay, so that's a lot of words, right? But we just need to think like, how much does it cost, right? So we have an initial fee, and then we have something that happens every month, right? So this is, right, this is going to be just like one time, and then this is going to be every month. So depending how many months we use the service affects the price, right? So we can look over here and we can think like, the price is dependent on the months. So if we were to make our xy, right, x is our independent, and y is dependent, right? So price is dependent, so this is price and this is months, right? So how do we do this? We have, so we have y equals 44 per month plus 48, where x equals months. So this is how we turn a word problem into an equation, right? Because x is our dependent variable, y is our price, right? We could write that. Right, our total cost of setting up and maintaining, right? Because this is our setup. Our setup is the one-time y-intercept, and our maintaining is this 44 per month. So if this is confusing to you, you just need a little bit of practice. It's really common to turn word problems into slope-intercepts. Okay, find the total cost of setting up and maintaining the website for 6 months. So we're just going to do y equals 44 times 6 plus 48. Let's just do this without a calculator. 44 times 6, we have 24. 6 times 4 is 24, plus 2 is 26. So we have 264 plus 48. 260 plus 40 would be 300, plus 12, 312. And remember to add that $sign, because this is a word problem and we need our units. Right, so in this one it would be dollars. So if you wanted to, you could write $312, but it would take more time instead of just using the dollar symbol. Okay, last two. Let's try this one. So we have step 1. we need to find our slope. So we go rise over run. So we go 2 over 4. But we want to be very careful, right? This is going from left to right. It's going down. So this should be negative, right? It's rising, but it's not rising. It's decreasing. So it's decreasing 2 going over 4. We want to simplify that to negative 1/2. Oh, let me make this more specific, right? We have m equals 2. We have b equals 1, right? Because we can see right here, it intercepts this y-axis right here at positive 1. And so 3, our final equation is y equals negative 1/2 x plus 1. A lot of you have noticed are like, when they go a little too fast, you forget this x. So if I see something like y equals negative 1/2 plus 1, I know that you know how to do it, which is great. You know, that makes me very happy. But if you don't put the x there, then it's wrong. Like, it's a simple fact, because if you don't put the x there, then you're essentially saying y equals negative 1/2 plus 1, which is just 1/2. And y equals 1/2 would be like this line right here, right? So you got to be very careful not to forget your variable, or else it completely changes your answer. All right, and then finally we have another example. You can try and pause the video and do it. If not, feel free to do it with me. All right, so we have m equals 13 minus 4 over 6 minus 0. So I'm going to start doing these really fast to show you like how long it takes, all right, once you know how to do it. And then 2, right, b equals 4. And so then our final answer is y equals 3 over 2x plus 4, right? Once you do it a lot, it should be that quick. You should remember the equation for the slope. You should remember to simplify it. You should know that this is going to be, right, our y-intercept, and then you just put it in the equation. So hopefully this is a review from previous slope-intercept stuff, but it's very good practice, so make sure you're doing those practice problems, especially the word ones, the application problems.